The derivative of sine is cosine of x. Very nice. Minus high d low sine of x. And then what's the derivative of the bottom? Okay, so the derivative of this part is negative sine x, but what's the derivative of 2?
Oh.
0.
Oh, yeah.
Okay, so just negative sine x times negative sine x. And then square the bottom, and away we go. Okay, so let's take a look then at the top and simplify. Okay, so what we did here is we did quotient rule and trig, and now we're going to simplify, and if possible, maybe, you know, if we remember any Pythagorean identities, which I was impressed on your last test, some of you guys did. Cosine squared, and stop me if you don't understand where I'm getting something from, minus 2 cosine of x, and then minus sine times minus sine, I'm going to write plus sine squared of x, and I'm just going to leave this as cosine of x minus 2 squared. I'm not going to try to expand that. Okie dokie. Anybody see it? Do you remember that little guy? Good. Cosine squared plus sine squared equals 1. So I'm going to go one more step, and I'm going to rewrite this as 1 minus 2 cosine of x on top over cosine of x minus 2 squared on the bottom. I will tell you that the hard thing, just like the hard thing with trig, is sometimes knowing where to stop. And, you know, like, could we try multiplying out cosine x minus 2 and cosine x minus 2 and seeing if we could? So sometimes today, like I already have the homework loaded, you know, the homework answers. Sometimes when you're checking, you might have done the derivative part right, but maybe you just didn't simplify in the way that the book did. So that can be tricky. All right. So then let's take a look at example 2. So now how is this related to what we did with 3-4 with position and velocity? So a weight is hanging from a spring and it bobs up and down with position function F equals 3 sine t, where S is in meters and t is in seconds. So let's find its velocity equation and its acceleration equation at time t. So how would I find its velocity equation?
Take the derivative of the position equation.
Mm-hmm. And so how would I find the derivative of 3 sine t? What would I write?
Negative cosine
t. Is derivative of sine negative cosine or?
3 cosine?
Yeah, it's just cosine. It's okay, that's why they're tricky. Derivative of cosine is negative. Here's how to remember, all the c's are negative. The derivative of cosine is negative, the derivative of cotangent is negative, the derivative of cosecant is negative. In my mind, that's what I tell myself. The 3 out in front doesn't matter, so this is going to be 3 cosine of t. Okay? How about then, to find the acceleration, I would take the derivative of the velocity. What's the acceleration going to be? Negative 3 sine t. Alright, you might be finding a pattern here. Do you remember with derivatives of powered functions, eventually the power keeps decreasing and we get down to 0? Is that going to happen with these? No, because then I go back to negative sine, and then it's negative cosine, and then the derivative of negative cosine is going to be a positive sine, and then I'm all the way back there again. Okay? And so with sines and cosines, when you take multiple step derivatives, we don't get down to derivatives of 0. So, hey, I talked about this before. A jerk. A jerk is actually a calculus thing. It's not a jerk, a big jerk. It is the derivative of the acceleration. So I like to think of it as like if there was some kind of quick motion, okay, that it's like even faster than an acceleration. It's the slope of the acceleration. So if a body's position at time t is, I should say, s of t, then a jerk is the derivative of the acceleration, or the triple derivative. So what would be the jerk of example 2 then? Good. Okay. Yeah. Because the derivative of sine is cosine, and the constant is -3. So the derivative is not negative cosine, but the -3 in front made it down. Okay? Okay. So we're going to use our calculator, especially when we're doing things with trig functions. If I don't give you a point that's an exact value on the unit circle, we can't use our calculators to find those things. Or we have to use our calculators. Like if this was a pi, I know the cosine, or I should know the cosine at pi, and I can find it. This is not. So this is a calculator question, and you can kind of follow those rules today on your homework too. If you are given a specific point and it is not a unit circle point, you're going to need to use your calculator to do that. All right, here we go. So we are going to find the equation of a line tangent to x times cosine of x at x equals 1. Anybody know what this involves? I'll draw a line to help you. Product rule and trig. Alright, so here we go. And then we will plug in the values we need. I'm doing this derivative because to find the tangent line I need the slope, right? And to find the slope I'm going to need to take the derivative. So here we go. First, d second. So x times, what's the derivative of cosine of x? Good. Negative sine of x plus second d first, so cosine of x times 1. Okay. Go ahead and get your calculators out a second, and let's plug 1 in, because this is going to give us then the slope of my line. So if I simplified this, by the way, that'd be negative x sine x plus cosine of x. So -1 times sine of 1 plus cosine of 1. For the slope, I get a negative, remember always 3 decimals, you can truncate or round, it doesn't matter in this case, is approximately -0.301. What else do I need for a tangent line? A point. And I know the x point. Let's go to the original and plug in to find y. So the point is 1 comma 1 times cosine of x, right? 1 times cosine of 1. So 0.540. Am I going too fast? Are you following this all right? So now, putting it all together, the equation for our tangent line is y minus 0.540 equals -0.301 parentheses x